Wanted to run through a quick tutorial on how to use the MTS Bionix machine for tensile testing. And the first thing you want to do is turn your computer on. You'll come over here to the HPU and you gotta supply the fluid to it, so that's just over here. Turn this valve with the black hose to the open position. You'll turn on your HPU by turning this knob clockwise to the on position, and then it'll take a minute to boot up. This is the screen that'll appear once it's done booting. You can just hit main display if it's in English, and then you'll hit, because of this faulted status, you'll hit your status and go ahead and reset the e-stop. Then you can go back to main and make sure that this remote operation button is selected. And that allows you to control the machine using the computer. Then back here on your controller, you want to turn that on with the white switch. Go ahead and turn on your monitor, and then the password is just password. It'll ask you to activate Windows. You can just hit cancel. Then the software that you're going to be using to control the machine is this station manager. And this computer shouldn't be connected to the internet because these software programs are susceptible to malware, so we just leave it unconnected and just download all your data to a USB drive. So the first thing you're going to do is hit open on this project 1. It'll pop up all the different displays, and you may need to wait while the CPU is connecting to the actual software, and this can take several minutes. The first display that's going to pop up, it's going to ask you, it will ask you to open up your configuration file. So here we use the strain plus the extensometer configuration, and then it'll pop up all of the different screens that are defaulted for this. And this first one is your basic testware. If that's not up and running, you can hit your applications and click on basic testware. And this is where a lot of your setup is going to start with. So if the tensile test isn't selected up here in the test name, you can actually open up a different TST file. We have a compression test and some other different configurations, so just make sure the tensile test is selected. And then you'll want to change your data file name for the test that you're doing. So you'll go to this test setup icon, and you have the command tab. You want to make sure you're in the monotonic type, and make sure you're in the displacement control mode. And then your rate, this is going to tell you how quickly the crosshead moves, and we usually set it based on the E8 standard for ASTM, and that's just dependent on reduced length of your dog bone section, so you can calculate that and figure it out. So we have it set to 0.5 millimeters per minute right now, and we're testing stainless steel and Inconel sub-size samples. For your data acquisition tab, you can choose different signals that you want to include as long as they're available in this left-hand display. And then we have time, displacement, force, and strain. If you have strain selected, you need to be using an extensometer in your test to be able to access that data. The data file, we can change the name of it just by choosing browse. You have to make sure you're in the user specified. Hit your browse, and then our naming standard is just the first 2 letters of your material. So in this case, we have Inconel, so IN, and it's 625 Inconel, and then a space with the test, and then the test number. And so in this case, the last one that was ran was test 8 for the Inconel. So we would just change that. If we were running an Inconel test, we would just change that to 9. Then you'd hit save. And then this just asks you if you want to use that directory for your data file, and that's yes. Then we can just exit out of this window. So the next thing we want to do is start up the hydraulic servos, and the way that we do that is by using these buttons down here. To be able to use the software though to control the machine, you have to have this exclusive control selected. An that's selected, we'll go ahead and start loading up those hydraulic servos. If you get an error here, then you may have to hit the reset button and then continue on. You want to wait until it stops blinking to go ahead and move to the next one. And here's that interlock 1 is active. Press reset to clear and override interlocks. So we'll reset and go into the next. And then that one didn't blink for long, so we can go ahead and move on to the high power. And make sure that you're wearing safety goggles whenever you're, or safety glasses whenever you're using the machine. So now that those are activated, you can control the machine either with this window down here called manual control, and you can control the displacement. So that's basically just telling the head of the jaws where they're going to be at. And you'll need to click this enable manual control to be able to do that. So as you can see right now, the machine, the jaws are sitting one on top of the other. And so we'll need to raise this up to be able to put in our specimen. Before we do that, you'll want to measure your specimen. And we're interested in getting the cross-sectional area of this reduced area section of the dog bone. So I just use a pair of calipers and I'll measure the width in 3 locations: at the top of the reduced section, in the middle, and at the end. And then sometimes if these are water jetted parts, they will have some slight curve from the water jet in the manufacturing process, and so you may have a wider side at the bottom and a smaller side up at the top. You may want to take measurements at both of those locations and average those out to get your area. And it's more of in the shape of a trapezoid than an actual rectangle if you look at the cross-sectional area. Then you'll want to make measurements of the the thickness in 3 locations, and then make sure to record those before you start your test. And I always like to put the Inconel 625 and then the test number that is that this is going to be run at. So this one was from test number 6. Okay, so to install your dog bone into the jaws, the first thing you want to do is you want to raise the head up so that you can get your piece in there. So you can do that from the machine or from the software. The software here, you would go into that manual control box, select enable manual control, and you're in the displacement tab in that drop down menu. And you can use this slider, or you can type in a specific number. And then as you change that, the head will move up and down based on your selection. So make sure that the crosshead is unlocked for you to be able to move the jaw up or down. So we'll go ahead and turn this knob clockwise to raise that head until we have sufficient space to be able to use our dog bone. Once we're ready to clip that in place, looks like we'll need to loosen up the lower jaw a little bit. To do that, you have these two knobs. This is for the upper, this is for the lower jaw. If you turn this counterclockwise, you'll see it opens and closes the jaw. So once it has enough space to open, you'll put it in like this, and then you'll want to make sure that you're not tilted front to back like this or back to front on an angle. You want to be as level as possible. And they have these little kind of indication marks on here on these jaws, if it'll focus on them. And you can kind of use those to help you on the top and bottom to kind of line it up in the center. It might help to scribe a little line on the middle of your dog bone on the top and the bottom. Make sure that your reduced section where those fillets start is just above the jaw top. And then when you clamp down, okay, so all you gotta do here is place your specimen like this, and then you will turn the lower jaw to the closed position, and you'll see the pressure gauge here saying 2000 psi. It's right where you want to be for any kind of steel or hardened metal. If you need to change that pressure, that gripping pressure, you can turn this knob counterclockwise, just make that a little bit lower. If you're using any kind of polymers or anything like that, then you want to be well below the 1000 range. Then once that specimen is loaded in that bottom jaw, should be holding as level as possible, perpendicular to those jaws. Then you'll come back into the software. Oh, and don't forget the strain gauge or the extensometer. What you'll do for this guy, it's really simple. You'll put in this zeroing pin like this, and then it has these little hooks that are just here on the edge, and those hooks just use these rubber bands. And so you'll grab these rubber bands with this little, I don't know what you call that, like a dentistry hook, and you'll hook that around the specimen, and I'll show you that in a second. So this is what the strain gauge looks like when it's attached to your dog bone specimen here. So it's really simple. All you do is you get that rubber band, you grab it around that hook, and then you place it on that other side. If you need to, then you can use this little kind of dentistry hook to grab that and pull it off. This extensometer can only travel a certain distance, and you'll be able to see that in the software in the scope 1 graph, and it will show you the strain as long as your signal, you could do it either, we generally have it on the x-axis. So in this x-axis, you have the channel on channel 1, and we can just change that to our strain, and then that will show us what the extensometer is reading, the force relative to the strain on the y and x axis there. And then once you've reached your yield, the extensometer will stretch as far as it is mechanically capable of doing, and then you'll notice on the graph that it just kind of goes crazy. And so once it does that, you'll want to disengage the bottom rubber band here, so you'll just pull that off, and then you can switch your signal that you're measuring from the strain back to displacement, and you can just watch your material as it peaks and then fails. So we're now ready to go ahead and clamp that top jaw over our specimen, but we do want to do some setup here. So you'll go to your signal auto offset to 0 the displacement, force, and the strain. So we'll zero out all of those values. You'll make sure you're in that channel 1 drop down, otherwise it doesn't show any of these values. Once we have that offset, we like to change this to the force control mode and make sure your enable manual control is selected. And I'll put a description to this in the PDF tutorial of why we do that, if you're curious. And then this is where all of our data is going to pop up once we start the test. So we got to clamp down our top now that our manual command is in force and we've zeroed our station signals. So we want to make sure that our crosshead is in the locked position before we clamp down on our jaw. We'll want to make sure that this is free to rotate, and so we want to make sure that it's lined up as parallel to the specimen as possible. And then once that's in place, then we can go ahead and turn the upper jaw knob to the close position. It's at 2000 psi. If it squeals like that, I like to turn it off and lock it again. And now when we're ready to test that the top and bottom jaws are engaged on the specimen and we've got the extensometer attached, we'll go ahead and we'll flip this to the rabbit mode. In the software, we are going to go ahead and uncheck the enable manual command. We will have to reset these locks on the system so that we can start the test. So we'll hit reset there. Then I always like to change the signal to strain, and I'll play the signal first, and then I will start my test. To start your test, all you're going to do is go over here, make sure that you have exclusive control selected, make sure your manual command, enable manual command box is unchecked, and make sure you don't have any errors being thrown. You should be in your high power for your hydraulics. Make sure you're in the rabbit mode, that your crosshead is locked, and that both of your top and jaw are in the locked position as well with the appropriate pressure applied. Then all we'll do is click on this program run, and I like to start this scope first and then hit the program run. And if you don't see anything at first, you may need to change the offsets. So in this case, our y-axis starts at 12 and our strain is starting at 0.001. So I'll go ahead and I'll change this offset by clicking in the offsets to 0, and then the same with the strain, and you'll see that graph starts to come into view now that we're in the zeros. It looks like we're still a little high here, so I can offset the Y to go up a little bit, and I can change the units, and that will get me fully in the location that I want. So this is measuring force in the Y direction and my strain here. So this is going to climb as the machine is pulling apart the specimen, and that extensometer is measuring that the change in that length from the original gauge length of 1 inch. And we'll see here that this graph is going to continue upward and then start to level out, and we'll get more deformation and strain rather than force. Once that starts to level out, we'll get like a little dip in the strain, in the force, sorry. And once we start seeing some weird up and down signaling going on, then we'll know that it's time to undo our extensometer. One thing I did forget to mention is to pull out your zeroing pin. Otherwise, your curve for your strain is going to look all wonky. If you don't pull the pin from your extensometer before you start the test, then you're going to get a graph that looks like this, where you just have a force increasing, but you're not getting any strain. But we know that the material is being strained, and so we should be seeing that strain along this graph. Once that takes a big dip and starts giving us some weird data, then we're going to go ahead and remove the bottom elastic, or you can remove both elastics while the remainder of the test is performed until failure. Okay, here we can start to see our force going down and our strain is staying the same. Once your material has reached failure, you'll hear that big pop, and then you'll go ahead and you'll hit stop, and then all of your test data is going to be saved to a directory that you can find here on the desktop called BTW. If you don't see it on the desktop, you can always double check in the data file directory or file path, and it's in that local disk MTS projects BTW. And so for ours, you can always select the date modified, and we've got the tutorial DAT file that we just did. And then this file can be opened up in Excel, and it will have a header, and that header will occur by default every 2000, and I believe it's 48 sample points. And so you'll see this header tell you the date and the test file name and the time, and then it'll have these seconds and units for the force and the strain and the displacement, and you can use these to calculate your stress strain and generate your stress strain curve and ultimate strength and yield stresses. So if we jump back into the software now that we're done and we've hit the stop button, we're going to want to remove the specimen. And so we'll go ahead and use this little hook to remove the extensometer. Sorry, it's hard to do with one hand. And so you'll just hook onto this that little wire, and you can just pull it off that hook. I'm just going to leave it on for now, just for sake of the video. So all we need to do now is let's go ahead and remove this bottom one. So we'll make sure that the crosshead is locked, and we'll change the speed to the turtle mode. And we'll go ahead and look for the lower jaw knob, and we'll go ahead and turn that to the open position. And then we can remove the lower specimen. And then to remove the top one, we do the same procedure. Just go to the top jaw. Then we'll go ahead and open that slightly so that it will open up the jaw enough to pull out our specimen. And then if you're going to measure the strain, if you marked your gauge length at the beginning of the test, you can do a manual, just kind of like a verification that your strain that you were getting was correct. You just kind of push those two specimen together, and here I just marked with a Sharpie. You can do it more accurately by scribing a line with a gauge, or some people use punches to center punch hole like small divots into the dog bone, and then you'll just measure between those 2 points, and then you'll say, okay, this is 1.6 inches. So the original gauge length was only 1 inch apart, so its strain is 60%. When you disengage these hydraulic servos, the top jaw will actually just slide down over time. Sometimes it can actually kind of fall onto the bottom jaw. So what I like to do when I finish my test is either go into the manual command, enable manual command, and then just, oops, wrong way, slide your slider down so that the top jaw is resting or really close to resting on the bottom jaw. And that way, if it does disengage, then you're not going to get them hitting each other really hard. The other option, if you don't want to use the software to do it, you'll want to uncheck the enable manual command, and you'll just come over here, you'll unlock your crosshead, and this raises it up if you turn clockwise and down if you turn it counterclockwise. And I go really, really slow, so I barely turn this thing. Until it is just barely above the lower jaw. And then once that's done, we can go back into the pumps. We'll power down our pumps and then go to power off, and then you can exit your software. And then from there, we can now turn off our Flex Test CPU, and we'll go ahead and shut off the HPU and the fluid that's being supplied to it by this black hose. Then all you have left to do is shut down your computer, and you'll want to make sure that you save your data file from here onto your thumb drive to do some post-processing.